People talk about once-in-a-lifetime jobs. This was once-in-a-century type opportunity.
Was my life. It's special. There's people from all over the world to come there and see this. It's not just like a little, regular church. It's people come here and see that, and even to this day when I go in there, I look up and it's like, whew, how did I do it?
This is the last major piece of internal embellishment that had to be finished to create a 100-year process for the church.
Logistics was, I would say, was 50% of the job. It was complicated. It was well thought out. We did a lot of thinking, a lot of logistics, getting things approved as in where we had to do steel or logistically enter the building, and everything was actually pretty nice. It was stringent, but it worked out to our benefit. All the steel and material basically went through two doors that were 6 foot by 9 foot. We had to design for it. We couldn't have something too large that wouldn't fit through the opening to get it inside the building. We just had to take in consideration, you didn't want a piece of steel show up or something show up that we couldn't get in the building.
One of the church's requirements was to remain open for televised and public services throughout the entire process of creating this dome. So that meant we had to develop a elevated structural steel platform. This really creates the most unique aspect of this project.
So we came up with the whole aspect of, okay, there's a lot of high work that is really, you're high risk. So I said, what can we do about getting it closer to the ground and then picking it up? Which the majority of the heavy duty work was done on the ground. It was 13 feet. When we built the columns, they had a gusset, and they were two-piece columns where we put the main truss in between it. That was 12 feet off the ground, which is a lot safer than 65 feet up in the air.
Building the platform close to the floor, it was safer for the men, and the logistics and the material handling was far safer. We had to develop a plan to design and erect a very complex steel platform that gave us a work platform 60 feet above the main floor, to design steel sections that were strong enough and heavy enough, yet small enough and slender enough to fit through the main original oak doors on the east transom to feed the center crossing. This is unusual because erecting structural steel for a building or a bridge is normally done with a crane because it's outdoors. This particular project was unusual because we're talking about massive shapes. Some as heavy as 40,000 pounds had to be manipulated and moved without the assistance of a crane. That was one of the biggest challenges that we had was developing pre-existing material handling equipment technologies that really had never been used in this type of application. And one of those was air casters. Air casters is a very interesting material handling equipment methodology where you're able to place aluminum manifolds underneath an existing load, hook it up to an air compressor, and literally levitate the load a quarter inch off the floor, and with minimal manpower and effort float and push very heavy loads across the floor without damaging the existing floor. One of the other inventive things that we did on this project was we employed the technology of strand jacks. Strand jacks relied on 300-ton jacks at each one of the four columns that descended special steel cables that connected to our steel. And then we were literally able to lift the entire platform as one unit over the course of 8 hours. This was a very tenuous period where we literally watched this massive 350,000-pound load inch up the wall, dependent on the hydraulic jacks that were lifting it. Once this platform was erected, we needed a method to get up to that platform. So we employed the use of the first construction elevator. It was a material and personnel manpower hoist that ran from the nave level up to the 60-foot level and allowed us to bring up all the smaller pieces of equipment that we needed to continue to build the platform. So this was a monumental accomplishment. It was the first big step that we had.
You can't get any dust in the church. So before we did any of that, we built the containment walls, ran ductwork, 4 exhaust units. We had 4 heat pump units up there to keep it acclimated to temperature at a constant 70 degrees, because 165 feet up in the church is either really hot or could be really cold. We're making so much dust. We could start sandblasting, and this huge space. When you start sandblasting it, the sandblasters, we had all our self-contained units, respirators, and everything else of air fed in, because you can't even see your hand in front of you, and this is a huge space. Well, you turn on the exhaust units, and within probably 35-40 minutes, the space would clear out. I mean, we probably went through thousands of dollars of filters because it's just the great volume of the dust was amazing. Not one speck of dust got in that church. I mean, we didn't have to wipe down anything. We wanted everything right, so everything went flawlessly. Safety is a major issue with us.
On a human level, the project was extremely successful, and not one person was hurt, and there were no accidents or damage to the building.
0 accidents.
This particular dome, it shows the Holy Trinity and the Blessed Mother, and then a procession of American saints or blesseds that had also visited the National Shrine. So kind of a unique embellishment of large figures. The background, or the background color of the dome, is primarily 24-karat gold mosaic, which was all produced in Venice. So the raw material itself is produced in Venice, and the actual artistic mosaic assembly was done in the town of Spilimbergo, Italy. The culture of working inside the Basilica is very thorough, which we really appreciate. And all of the original domes had vermiculite plaster, which is a gypsum-based plaster that was blown in on top of the Gustavino tile. So a big part of our task on this project was to remove all the old gypsum down to the original Gustavino terracotta clay tile, sandblast and abrade and clean that, and then apply 3 coats of Portland cement plaster and allow that to cure out at the right time, so that we had a suitable substrate of very hard cement, impervious to water, for the new mosaic to be attached to. So that's a very tricky process, because we have to guarantee that the new plaster follows the exact curvature and geometry of the original plaster, because we are producing the glass mosaic at the same time as we are doing the demo and the new placement, and the measurements for the mosaic were done based upon the original plaster that had to be removed. We were given a special medal of accommodation for service to the church by Pope Francis, and this was the Benedetti Medal, which was a great honor and something I hold in really high esteem. And I feel very grateful to have been recognized by the Pope, and I think that's one of the most special things on a personal level that occurred in terms of recognition. It was just an incredibly busy at times stressful process, but I'm just so grateful that it ended up without any accidents, no injuries, ahead of schedule, and the workmanship is just stunning.